Hello. Today we are going to learn how to calculate the equivalent weight of the substances involved in disproportionation reaction. Okay, let us take an example. Say bromine reacts with concentrated sodium hydroxide solution, sodium hydroxide concentrated, to produce sodium bromate NaBrO3 plus NaBr sodium bromide plus H2O. Okay. Now this is a disproportionation reaction because the oxidation number of bromine is 0 here, oxidation number of bromine is +5 here, and oxidation number of bromine is -1 here. So actually bromine is oxidized to bromate ion and simultaneously it is reduced to bromate ion. It is reduced to bromide ion. So this oxidation and reduction process occurs simultaneously. So this is a disproportionation reaction. Now we have to calculate the equivalent weight of bromine in this reaction. First of all, let us consider the oxidation half reaction. Oxidation half reaction. Oxidation half reaction. Oxidation half reaction. This is bromine plus hydroxide ion to produce BrO3 minus. This is our bromate ion plus H2O plus, here the oxidation of bromine is 0, here the oxidation of bromine is +5. So 2 bromine atom here, so 2 bromate ion will be formed and there will be a release of 10 electrons because the oxidation number of bromine is changed from 0 to +5. 2 bromine atoms are there, so 5 into 2, this is 10 electrons. These 10 electrons will be released. Now we have to balance this hydroxide and water. Say 12 hydroxide here, it's 6 H2O here. So the oxygen and hydrogen atoms are balanced. Say this is our equation number 1, the oxidation half reaction. This is our equation number 1. Let us consider the reduction half reaction. Reduction half reaction. In the reduction half reaction, bromine is reduced by accepting 2 electrons to produce 2 Br minus ions. So the oxidation number of bromine is 0 here and it is -1 here. So 2 bromine atoms accept 2 electrons to produce bromide ion. So this is our equation number 2. This is the reduction half reaction. Okay. Now we have to balance this oxidation half reaction and reduction half reaction by equalizing the electrons. Here 10 electrons are released and here 2 electrons are gained. So we have to balance the number of electrons gained and number of electrons lost. So we have to multiply equation number 1 by simply 1 and equation number 2 by 5. Yields bromine plus 12 OH minus 2 BrO3 minus plus 6 H2O plus 10 electrons. And again multiplying this equation by 5, we have 5 Br2 plus 10 electrons gives us 10 Br minus. So if we add these two reactions, we have the net reaction. The net reaction. The net reaction is 6Br2 plus 12 hydroxide ion to produce 2 bromate ion plus 10 Br minus plus 6 electrons. This is our balanced ionic equation of this disproportionation reaction. Now we have to calculate the equivalent weight, which is our target. Now the equivalent weight of bromine can be calculated in 3 different ways. In many ways, we considered only 3 methods. The method 1, first we considered method 1. In method 1, the equivalent weight of bromine is equal to molecular mass of bromine divided by number of electrons involved in the oxidation process. This is 10 plus molecular mass of bromine divided by number of electrons involved in the reduction process. This is 2. This gives us, now molecular mass of bromine, atomic mass of bromine is 80 into 2 divided by 10 plus molecular mass of bromine, that is 80 into 2 divided by 2 gives us 16 plus 80, this is 96. This is the equivalent mass of bromine. This is our method 1. Next, we consider method 2. Method 2. Now, we know a formula 1 by n, this is equal to 1 by n1 plus 1 by n2. This is the formula for calculating n factor for a disproportionation reaction, where n is the n factor of the net reaction, n1 is the n factor of the oxidation process, and n2 is the n factor of the reduction reaction. So, here we calculate n in this way. 1 by n1 means 10 plus n2 means 2. This is 1 by n, this is 6 by 10, yields n equal to 10 by 6, this is 5 by 3. This is the n factor of a bromine here. Now we know the equivalent weight. We know equivalent weight or equivalent mass of bromine. This is equal to molecular mass of bromine divided by the n factor, and the n factor is also known as valency factor. Now the n factor of this reaction is 5 by 3. So molecular mass of bromine, this is 80 into 2 divided by n factor is 5 by 3, gives us 80 into 6 divided by 5. This is 16 into 6, this is our 96. It is the equivalent weight of bromine again. Let us consider the method 3. Method 3. Method 3. Now we can think this reaction in this way, that the bromine is the only oxidant and reductant here. So we can consider this reaction in this way, that there are 2 types of bromine. Here again it is bromine. One bromine molecule is oxidized to bromate ion, gives us 2 BrO3 minus, and again the 5 bromine atoms, 5 bromine molecules are reduced to 10 Br minus. So the oxidation number of bromine is 0 here, it is plus 5, it is minus 1, and it is 0. So we can think in this way, that the 5 electrons, 5 into 2, this is 10 electrons is released by this bromine molecule, and these 10 electrons are received by these 5 bromine molecules. So we can say 10 electrons are exchanged between these 6 bromine molecules. So we can calculate the n factor of this reaction in this way, that n factor of this reaction is equal to number of electron exchanged, this is 10, divided by total number of molecules involved in this reaction, this is 6, gives us the n factor equal to 5 by 3. Therefore equivalent weight equal to molecular weight 80 into 2 divided by 5 by 3, again gives us 96. This is the equivalent weight of bromine in this reaction. Let us consider some similar reactions which occurs in the disproportionation manner. Let us consider the reaction of chlorine with concentrated sodium hydroxide. Now chlorine reacts with concentrated sodium hydroxide in the similar manner to form sodium chlorate NaClO3 plus 5 NaCl sodium chloride plus 6H2. This is not 5, this is 10. Okay, it is 2. Okay. Now we can calculate the equivalent weight of chlorine in the similar manner. The equivalent weight of chlorine equal to molecular mass of chlorine, this is m of Cl2, divided by, again the n factor is 5 by 3 in the similar manner. So we have 35.5 into 2 divided by 5 by 3 gives us 35.5 into 6 divided by 5 equal to 213 divided by 5 is 42.6. This is the equivalent weight of chlorine in this disproportionation reaction. Again, we know chlorine reacts with sodium hydroxide. This is dilute sodium hydroxide. This is concentrated sodium hydroxide, and this is dilute sodium hydroxide to produce sodium hypochlorite NaOCl plus sodium chloride plus water. So this is again a disproportionation reaction where the oxidation number of chlorine is changed from 0 to +1 and simultaneously 0 to -1. This is again a disproportionation reaction. So the n factor can be calculated in this way, that the chlorine, this is Cl2, this is again Cl2. Say this chlorine is oxidized to OCl minus, the oxidation number of chlorine is +1 here, and this chlorine is reduced to Cl minus, the oxidation number of chlorine is -1 here. So this oxidation number 0 here is 0. So two chlorine atoms are oxidized to hypochlorite, and two chlorine molecules, the two chlorine atoms are reduced to chloride ion. So you can say that 2 electrons is transferred from here to here. This chlorine atoms, this chlorine molecule releases 2 electrons, and these 2 electrons are accepted by this chlorine molecule. So the n factor of this reaction, n factor of chlorine in this reaction, n factor of Cl2 equal to number of electron transferred, this is 2. 2 electrons are transferred between 2 chlorine molecules. So this is 2, this is nothing but the n factor is 1. So the equivalent weight of chlorine in this reaction is molecular mass, that is 35.5 into 2 divided by 1, yields 71. Okay, so this is the equivalent of weight of chlorine in this reaction. Okay, this is all about our lesson today. Thanks for watching the video.